right, everybody. Welcome to our last official packet of the year. Next week's got some field day items, so I don't know exactly what that's going to look like. So this is the last kind of print it out and do it packet. And you'll see that on the top of this packet, it is all just math this time. In fact, it says grade 4 end of year test. What I don't want you to do is to freak out. So if this will make you feel better if you do this, feel free to do that. End of year. So this packet is pretty much going to cover just about everything you've done this year, which is totally unfair. Without any kind of review or talking about it, just to slap this thing down is kind of ridiculous. So I'll just kind of breeze through it real quick. What I'd like you to do is spend your time this week working on this and do the ones you can do. But then also don't really sweat the ones you can't do or haven't remembered or it's been a while, because you'll get a chance to refresh all that stuff beginning of next year. But I do want these to be turned in as many, more than any other packet so far. I want this one to get turned into me, whether taking pictures or dropping them off, because this will give our 5th grade teachers a little bit of a heads up as to maybe there's something in there they really need to go over again, and maybe some stuff we've got. Okay, so this will be quick. This one is talking about writing equations. So remember, letters meaning words. And so in this case, it says the equation K equals 2B compares the number of hats Kevin, K, his brother, B, have. Describe the comparison shown in the equation. So Kevin equals 2B. And remember, in algebra world, whenever there's a number just stuck right next to a letter, that means they're getting multiplied together. So in this case, Kevin equals 2 times B. So it wants you to say, describe the comparison shown in the relationship. What does this mean? What's happening here? If Kevin's got 3 hats, how much does his brother have? That kind of thing. Same down here, except for this time I think you're going to, because it says, write a multiplication equation that compares the numbers of mazes and riddles. And if you want to find a letter, probably M for mazes and R for riddles. And I see a 3 times in there, so figure out how you're all going to slap those together. Write an equation to solve the problem, then solve. So the bottom line is, you're going to solve these ones, right? And remember, when we do story problems, it's often good to kind of quickly search for the last line. How many lemonades did it sell? So you're looking for a number of lemonades. On this one here, how many days will it take for her to memorize all the lines in a poem? So you're looking for an answer in days. Down here, total cost of the tickets. So usually when you see that, there's going to be a plus, maybe a multiply. That's that kind of problem. All right, on to the next page. Flea market. Hillary bought 2 headbands for $3 each and 2 belts for $6 each. She paid with a $20 bill. Write an equation to show how much money Hillary will get back. Whenever you see this, you know there's going to be some sort of minusing happening, right? This is factor pairs. Remember, factors are 2 numbers that you can multiply to make this number. So it wants to see if you can get all of them. We started doing that factor rainbow thing, but literally we did 2 of them. So here's an example. 1 times 54. Those are factor pairs. What else could I multiply together to make 54? Remember, it says, is 39 prime or composite? Composite is most of all the numbers out there. And prime means you can only multiply, the only factor pair for it is 1 times 39. If you search around and can't find any other way to multiply to make 39, then it's going to be prime. Pattern stuff here, use a rule to find the next 3 in the pattern. The rule is multiply by 3. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. Keep on going. The number should get pretty big. And then pattern stuff down below. We're off to numbers and operations in base 10. Look at the number. How many times as great is the value of the digit 8 in the hundreds place than the tens? So how much, what times this would make it into there? How many more times is an 800 versus an 80? What is the number written in word form? So see if you can write that whole one out. You're comparing these two. Who's bigger, right? And then down here, we have some rounded to the nearest 1,000. Round it to the nearest 1,000. So find 1,000 in here. There's the 1,000 spot. Look at his next door neighbor. So ask yourself, is it going to be 396,000 or up to 397,000? Let's see, tickets. How many tickets were sold in all? Usually that means an add, maybe a multiply. Got a couple of mountains here, Mount Washington in New Hampshire, and then we have Iroquois Peak in New York. Question is, how much higher is Mount Washington? You know, when you're comparing two things, how much higher, how much taller, how much more, how much less, it's going to be a subtract problem in there somewhere. You're finding the difference between the two. Harper bought 3 coats on sale. Each coat cost $118, total cost of the coats. So yeah, it's going to be either adding 3 of those coats or multiplying. And speaking of multiplying, remember these guys, an area model. This is a super one here, super area model. Remember how these work? This number times this number goes in this box. So 30 times 20 is the same as 3 times 2. That's 6, right? Plus the 2 zeros I just hid, 600. And now that's 30 times there, and then 30 times 6 goes in this box. So 3 times 6 plus a 0. And then I work my way down here. 20, well, I can do it this way too, right? 20 times 4, and then 4 times 6 in this box. When you get all your boxes, add them all up and you get your answer. You could also do, it says it wants you to use the area model, but if you really want to, you probably could just do this, even to just check it at the end, right? You're just multiplying. And, oh, hello, long division. Divide, multiply, subtract, bring down, right? How many 4s will go into 1? Multiply, subtract, bring down. How many 4s can go into 1 without going over? 0. Multiply. 0 times 4 is 0. Subtract. Bring down the 2. And then I start at the top again. How many 4s can go into 12 without going over? 3. And then keep on going. Multiply. 3 times 4 is. You might want to move this whole operation over here so you've got some room to work with here. Gardener is planting 112 flowers in 7 rows. Write and solve an equation to show how many flowers are in each row. You've got a big pile being broken into smaller piles. This is a notorious division problem. So I would make these 2 numbers look like this and just go for it. Finally, we're off to fractions, which is kind of what we've been doing the past month now. 5 fractions that are equivalent to 1/5. Remember what I said? Multiply both the top and the bottom by the same thing. 1/5. If I'm multiplying both by 2, I'll get 2/10. There's one equivalent fraction. I can double that again. I can double that again. So you want 5 of them that are equivalent to 1/5. You're going to compare these 2 with fraction strips. It wants to know pretty much which is bigger, 3/4 or 7/8, and you can color them on in to find out. It says who finished more of their social studies homework. Now here, we have a contest between 2/3 and 5/8, and not many of our tricks will work on this one. Right? Don't forget our little tricks here. Bottom numbers, larger top number. Let's see. Bottom numbers are different. Top numbers are different. So nope, nope. If either fraction is more or less than 1/2, let's find out. 5/8, 4/8 would be exactly 1/2, so 5/8 is a little bit more. 2/3, it's not going to help us out either. So our tricks won't work for this one. You might have to do a little bit of grinding. Remember, to solve these ones, if the bottom numbers are the same, then life would be easy, right? And so we got to find a number that both of them can meet at. And if we count by 8s, we'll get 8, 16, 24, 32. If we count by 3s, 3, 6, 9, 12, 15, 18, 21, 24, right? So it looks like the first number they both can meet at is 24. I'll leave the rest up to you guys to figure out how to change these fractions so they've got 24 at the bottom to see who's bigger. Not just add these fractions, but for whatever reason it says explain how to add these fractions. This seems like a pretty easy problem, especially compared to the one just above it. So I'm more concerned that you can do it, but if you can explain it, that's great. Complete the equation. 9/12 is the same as 3/12 plus 4/12 plus some other fraction that's going to make it end up at 9/12. And then here's Derek at the community center. The question is, how long is Derek at the community center? Looks like you're going to be adding a couple of mixed numbers. 1 1/4 plus 1 2/4. Almost to the last page. This is the penultimate page here. How many more pounds of shrimp does she buy than scallops? So how many more? Looks like a subtraction problem to me. How many pints of berries does Troy use in all? Probably an add problem. Or in this case, I see 3 1/2, and so maybe it'll be multiply, but we haven't done multiply yet, so add. Let's see, how much more velvet? That looks like a subtraction problem to me. Write the fraction as a product, in other words, as a multiply, of a whole number and a unit fraction. So what? And remember the unit fraction is, with the 8 on the bottom, the unit fraction will be 1/8. So some big number times 1/8 equals 7/8. And then, similarly down here, use the model to find the product. 2 times 5/6 is going to equal how many sixths? You can count them up if you'd like to. Let's see. Write and solve an equation to find how far Paloma walks her dog on Saturday. She walks her dog 7/8 of a mile every day after school. She walks her dog 4 times. Gotta be multiply, huh? That times 4. Write an equivalent fraction with the denominator of 100. So 3/10 is the same as how many hundredths? That's what it's looking for. Let's see this last one. Write 6 100ths as a decimal. We did this last week. So 6 over 100 is the same as what? Is it going to be 0.6, 0.06? Remember, 100 on the bottom. Compare the two. Oh, this is easy. So we're just going to compare these two decimals here. Greater than, less than, or equal to. And then, last page. What is the distance in meters? Well, this is going to be a great page for you because we didn't even get to this stuff during quarantine. So this is a conversion between kilometers and meters. So give it your best shot. 37. He bought 4 pounds of squash. How much does each squash weigh in ounces? You're converting between pounds and ounces. Again, best of luck to you there. Something you haven't been taught this year. How many millimeters did the second ant carry the crumb? You're converting between centimeters and millimeters. So again, go for it. Soccer practice starts at 1:15, ends at 2:35. How long was it? This is an elapsed time. You can do this one. Whereas 36, 37, and 38, we have talked about elapsed time. And last two. Edgar has enough paint to paint a wall. A total wall area of 200 square feet. The walls are 8 feet tall. What lengths of walls can Edgar paint? Show your work. And so it's 8. If it's 8 high, how far could it be? They want to know before you run out of paint. 8 times something up top, and you can't get bigger than 200 in here. Lastly, it says, Ava cuts rectangular strips of plastic to make a mobile. The line plot shows the lengths of strips. What is the difference in length between shortest and longest strip? So it wants when you see difference, remember you're going to be doing some subtracting. So find the shortest strip, which is this one, and the longest strip, which is this one, and then I would subtract them and find out what the difference in between them is. So that's it, you guys. It's just 41 problems. I say just 41 problems, but there is no ELA. There are no ELA pages for this week, and this is a no pressure situation. But I do want this turned in because the 5th grade teachers will be taking a look at this to double check and see what they have to go over in the beginning of next year with you guys. So with that being said, have a wonderful week, you guys.